Hi, this is Ashley, and this is a brief tutorial video on engineering economy. First, let's look at the P or the F given P formula, or the future given present formula. It is used to calculate the single payment future worth, or F, given a certain time period and interest rate, and also the present or provided present value. So this example here shows us that there is a cash flow diagram, or a CFD. In your first year, you're given $5,000, and there's a period of 10 years total, so n equals 10. Your interest rate is 4%. So to solve this simple problem, you would use the formula listed right here. And the specific formula is up here. The nomenclature for that formula is listed down here. And if you just substitute all those numbers into their proper location in the formula, you can calculate that in MATLAB or in R, which is another software that I've used. And both of these will produce generally the same answer, given a couple of rounding errors. So that's pretty simple and easy. The idea of future given present is that you have a present value of 5,000 and you want to compute it or calculate and see how much that $5,000 will be worth in a future of 10 years. So that is really what this formula is generating for you. And you can see that the MATLAB code here and the R code both gave us the same answer of $7,401. And now let's look at number 2, discuss what this is all about, the present given future. Much like the same problem, we're calculating the single payment or present value, P or PV, after a certain time period with a certain interest rate, and you're provided with the future worth. So much like the CFD for the other problem, we have 10 years, but in the 10th year, we're given the future value as 5,000, and we need to calculate the present worth, or what it would have been worth initially, given this I, or interest, of 0.05 or 5% in years as 10 years. So we use the formula listed above, type in the nomenclature for that formula, and then insert or substitute the numbers that we've been provided, calculate it using MATLAB or R, or a simple calculator would do. And both of those numbers will give you $3,069.57. So at the beginning of this 10-year period, you were given that specific 3,000 some odd change amount, and over time, over 10 years, given your interest rate, you actually are coming out with a future worth of $5,000. So that's pretty nice. Now let's go ahead and look at the third problem here. It says to discuss the future given annual amount, and that is pretty simple as well. You simply have to calculate the compound amount, or the future worth, after a certain time period, given a certain interest, and provided the annual equal payment series. So your CFD for this example would be something like this. You have a time period of 10 years, an interest rate of 2%, and each year the series, or the uniform annual series, is $1,000. So every year for 10 years you're given $1,000. And you want to calculate what that future worth will be at your 10th year. So how much would all of this be worth? Let's say you were given all of this money in one lump sum at the very 10th year, the very last year, and what would that exact amount be if you were to add up all of those and put them right here under this 10th year? You would use the formula that's listed above, and using the nomenclature F given A, you would substitute in the numbers that you've been provided. Once again, using MATLAB and R, you would calculate it to be $10,949.72. So after you've been given $1,000 for a year with 2% interest for 10 years, you will come out with $10,949. And now let's move on to the fourth thing that we must discuss, which is finding the annual given the future. So in this case, you have a time period of 10 years for your CFD. Let's fix this. CFD. And then in your 10th year, your future worth is $20,000. Now, you have a 3% interest of 10 years, And now we want to see how we can divide up that future worth into 10 different annual amounts that will sum together to give us this specific future worth. So much like we did in the previous problem, but just the inverse of that. So now we have our nomenclature written down here, and we substitute in all of our given information, calculate it using MATLAB or R, and you should get $1,414.14 as your annual uniform series. So each one of these years you will be given about $1,400 each year to give you $20,000 for your future worth, or your future amount. And now let's look at the fifth thing that we must discuss, which is the present given annual series, uniform annual series. Now your uniform annual series is just like your other series, with 10 years given a 4% interest this time, and each year you're given $1,000. Now you simply use the same nomenclature to calculate this present worth, and then you will substitute your information into that formula, just like the formula has listed. Insert that information into MATLAB or R to calculate or compute your amounts. And so for your present worth, now we're trying to see exactly how much you would have to be given at the very start, given this amount of interest. And at the very start, you would have to have $8,110.90. Now let's move on to the next possible problem. You could be asked to find the present worth. You could be asked to find the present worth, or the uniform annual rate according to your present worth. So this is what your CFD looks like. Sorry, I must have been messing up with that. But this is what your CFD looks like. You're given $25,000 initially for your present worth, and you're going to try to transform that into a uniform annual sum, or a uniform annual rate or series amongst this 10-year span right here with a 6% interest. So using this formula up here, you will simply type in the nomenclature, substitute in the information, and calculate it using MATLAB or R, just like the other ones, and you will find that you will have to have a $3,396.70 for each of those years in your uniform series. Now let's move on to the next question, which is to discuss your annual given a gradient, or a uniform gradient series. Now this series is a little different looking because right here your CFD has not been drawn to scale. So usually these arrows will be, the length of them is according to the magnitude of the amount that you are given each year. So these arrows going along would be a little bigger each time. You can see that they increase by $1,000 every year. And knowing that, you can see that each one of them are representing the amount before, and so the gradient of each year is $1,000. So now if you were given your interest rate being 4% and a 10 years amount of time, you can type in the information or substitute the information that you are given into the formula and then calculate it using MATLAB or R, and you can find that your annual rate, or the uniform annual sum, or the uniform annual series, I apologize, would be $19,244.36 for each year. That would be your uniform annual amount. And now as we scroll down again, let's look and just change topics here. Let's look at the combination and permutations information. So to discuss the combination and permutations, this is pretty simple, saying that combinations are when you have numbers or observations, and the observations are really the only thing that matters. The order does not matter, but for permutations, the order is highly important. So you also, not only do you have to have the number or the observations required, you also have to have them in a specific order. And now to discuss the specific combinations in manufacturing processes versus permutations in manufacturing processes, well, this is pretty self-explanatory. Permutations, given that you have to have them in a specific order or that order matters, this would apply to things such as like a series or an assembly line. And combinations, well, this could be for simply like a combination, such as if you're mixing something together and it doesn't matter what order you put it in necessarily, you just have to have all the ingredients. Something similar or along those lines would be fine. And this is a simple joke that my professor likes, and it's just pointing out the fact that often in our English language we do not use the correct terms for things or specific calculations, so a combination lock should really be called a permutation lock because the order really does matter. You can't turn a lock to 10, 17, and 23 and expect to get the same result as if you typed in or turned the lock to 23, 17, 10. You simply can't do that. So make sure that you know the difference between permutations and combinations because it's very important. I hope you've enjoyed this video. Thank you.